Wow, look at that. We're here at Lake George looking at a famous rock outcropping. This rock outcropping is made of the remains of ancient sea organisms called stromatolites. You can actually see the layers of material built up by these ancient organisms. We know that calcite bubbles in acid, and limestone is made of calcite. So we can see if this rock bubbles in acid, and if it does, we can assume that it's probably limestone. Well, I see some bubbling right there. So bioclastic and made of calcite, it must be fossil limestone.
Nice job, Jason. Let's go to the Catskills. So I don't see any interlocking crystals, so I know it's not igneous rock. But look at all these dull particles. And some of them are several centimeters wide. But what kind of rock is it? Well, it's clastic because of the cemented particles. Some particles are a centimeter across and rounded. It must be conglomerate.
Sounds right to me. Let's go to the salt mines.
Hey, this reminds me of that experiment that we did with sedimentary Sam. Look at all the crystallized salt.
Hundreds of millions of years ago, New York State was covered by a shallow ocean. As this ocean evaporated, the salt that was in it precipitated out and formed these huge salt deposits we're in now. Now, these salt deposits are hundreds of feet beneath the Finger Lakes.
But how do you know it's all salt?
Well, taste it. Ugh, yeah, that's salt.
So we've shown you some information about sedimentary rocks and igneous rocks. Now it's time for a change.
A metamorphosis.
Metamorphic rocks form from intense heat and pressure. When continents collide, these rocks are buried tens of kilometers deep and put under intense, extreme heat and pressure. Any type of rock can be metamorphosed under these conditions.
Under this intense pressure, the particles of sedimentary rocks turn into crystals. The greater the heat and pressure, the more metamorphism occurs, creating larger crystals.
Sometimes new crystals can form under intense heat and pressure, such as garnet and mica.
And the mineral mica gets flattened or foliated and forms foliated metamorphic rocks.
Sometimes rocks like granite with many minerals are metamorphosed. When this happens, similar minerals are compressed together to form bands.
And finally, the rock can even be distorted or folded.
Wow, that's a lot! I know, it sounds like a lot, but it's not that bad. When identifying metamorphic rocks, you want to look for crystals that are foliated or banded. Look for distortion, or look for unique minerals like mica and garnet.
And don't forget, the scheme for identifying metamorphic rock in the Earth Science Reference Table should help. The scheme for metamorphic rock identification divides rocks into two groups, foliated and non-foliated. Foliated rocks are listed from least to most metamorphosed and are identified by mineral composition and crystal size. The non-foliated rocks all have unique characteristics. For example, metaconglomerate has flattened pebbles, while quartzite and marble are both monomineralic.
I know where there's a ton of metamorphic rocks, in the Taconic Mountains. Let's go!
Definitely.
We are in the Taconic Mountains of eastern New York. As we head east from New York to Vermont, we find a classic example of foliated metamorphic rocks called the
Taconic sequence.
Anyways, as we head from west to east, we'll find rocks that were buried deeper and deeper, resulting in higher and higher grades of metamorphism.
The rock is dull and made of lots of particles. I mean, this doesn't seem metamorphic to me.
Right. That's a sedimentary rock called shale. It wasn't buried deep enough to be metamorphosed. If we head east to Granville, we'll find what happens to this rock when it is buried deep enough.
Alright, so this looks like shale, but it's stronger and shinier.
Right. This was shale, but it was buried deep enough that heat and pressure turned the clay particles into microscopic mica crystals. That's why it's shiny.
So on the Earth Science Reference Table, if you have something that's foliated, that's got tiny grain size, and made of mica, this must be slate.
You got it. Hey, can we wipe the slate clean and be friends?
Sure, hold on. So if we go further east, we will then be able to find rock buried deeper.
Yeah, we can't go further east.
Why can't we go further east?
Vermont's to the east.
And why can't we go to Vermont?
Because this is about New York State rocks.
We went to California.
Yeah, we shouldn't have done that.
All right, well, I know a spot where we can go and get rock like Vermont, but stay in New York.
The rocks of Central Park are beautiful, and like the rocks of Vermont, they're foliated and contain coarse-grained mica crystals.
So, coarse mica crystals and foliation looks like schist.
So Manhattan's built on schist?
Ugh. Well, I hear the Adirondacks are nice. Let's go there.
Here we are at an old church in the Adirondacks. Often old buildings like this are made from stones quarried locally. So it's likely that this rock is from right around here. Now here's a rock that looks different from the rest. I see that it has interlocking crystals, so that must make it igneous.
Not quite. What you see here are the different colored minerals forming bands, making it metamorphic.
Oh, that's a nice rock.
That's exactly right. It's a metamorphic rock called gneiss, and it's made under only the most extreme heats and pressures.
Well, what would happen if we put it under even more heat and pressure?
It would just melt and form magma.
Can we look at one more rock?
Fine. Oh, okay. So this is the distortion I was talking about earlier.
Right, so that tells us this is a metamorphic rock, but what kind is it?
Well, it bubbles in acid like limestone, but unlike limestone, this is made from crystals.
So according to our earth science reference table, it's made of calcite and metamorphic. It must be metamorphosed limestone or marble.
Unfortunately, we're out of time, but we did manage to show you 3 types of rocks: igneous, sedimentary, and metamorphic.
We've shown you how each type of rock forms and how to identify them using your earth science reference tables. We hope you've learned a lot.
But it's going to take a lot of practice before you're good at identifying rocks, so get to work.
And until next time,
have a nice day.